But we'll talk about network automation. Now, this is a little rough on this one, as some of it is the first time for me delivering this particular material, because this is the brand new material introduced in this new version of the material. So generally it takes me a couple of run-throughs before I've got everything down pat. So in this one we'll be looking at discussing cloud computing and virtualization again, but we'll be it started at chapter 14 instead of chapter 15. No. What's going on here? You know what? Okay, that threw me. Okay, see this? They've put the same objective slide into both chapter 13 and 14, and I'm going, hang on, this is the wrong chapter. That's the one we did last. Okay, so what we have is automation. So we're going to be looking at automation and languages. So ignore the objective one screen. So apologies for that one. All right, so I'm going to have to go through and make my own objectives page because they've included the wrong one in the standard pack. And I didn't pick it up when I skipped through this power pack earlier. So automation is the process of basically scripting up changes so that we can have automatic rebuilds and things like that. So we collect a large amount of data during automation, and we need to quickly analyze it and change and adjust settings based on those events and processes that are occurring. So within automation, you think of robots, and in mining, firefighting, even in plant automation, okay? Because these things are just moving around, they can cause a risk to humans because they don't have all these little soft points to stop them from just doing what's pre-programmed into them. So they'll swing around and knock a human flying and continue on working because they don't have the inbuilt sensors to detect that something is obstructing their normal movement, because they all work on the assumption that the area that they're working in is clear of soft targets, being us humans. So we need to improve the automation process to make it more smarter so that we can include the feedback and analysis into the routines. Otherwise, they're just devices running on a pre-programmed track, basically. So what we need to do is incorporate new technologies that are adaptive to their environments as those environments change. The main leading factor in this is in our self-driving car pursuits. So we need to have this technology where it's taking in its environment and getting all of these sensory inputs about the changing environment and making an analysis of those inputs and making decisions. These actions need to be based on set circumstances because, you know, it's programming. So we need to be able to program the thinking elements into automation tools. So to do this, we need to have some form of storing large data sets that these thinking routines use as their reference points. Hypertext is one standard of markup language that allows us to have structure, but normal data formats that other applications other than web pages use are JavaScript object notation, JSON. Then we have the extensible markup language, XML, which we see in everyday use in web pages. YAML ain't markup language. That's an interesting one. So we need to use the appropriate data sets for the applications we want to use and the scripts. Okay, so we're trying to create tools and we need the support structure in behind these tools to be of the right interpretation. So data formats always have a structure, a grammar. So this syntax will be a combination of bracket types, quotations, spaces, commas, right? And these characters and strings will represent specific elements that we want to have. So we normally have a key that identifies or describes some data, and the data is the value, whether it's a character, a string, a number, a list, whatever it is. So let's have a look at some of the different ways of representing the same message. All right, so on the left we have JSON format. So the message success, timestamp, position, latitude and longitude is repeated in very different formats, but they all represent the same information. So what we're looking at is a human readable data format, JSON. It's very popular and is used in web servers for APIs to provide public data. It's very easy to parse and can be used by many new languages, including Python, which is one of the largest automation languages out there. It's not the only one, it's just one of them. So when we have an output from our interface, we have the interface name and its status, a description and its IP address. So we want to compile this output into the format so that we can keep all the variables and information intact. So to get that into storage in a JSON format so that that data can be stored, it takes a bit of coding. And as with everything, you'll get better at this coding and scripting as you practice it. Now, me looking at JSON and all the brackets, that reminds me of an old language that I started off using many, many moons ago called Lisp. We would use brackets in the same format, but alright, so the syntax rules are hierarchical structure, and it contains nested values, and it uses the braces to hold objects and the square brackets to hold arrays, and data is written in the pair of key values. So keys must be strings with a double quotation mark. Values must be valid JSON data types, and it lists all the other types there. And the keys and values are separated by a colon. When we have multiple pairs, these are separated by commas. And white space is not significant in the data set. So we have the ability to create arrays. Arrays are lists of values. So the keys followed by a colon and a list of values enclosed in square brackets. The array is an order of lists and values. You can have multiple types. You can mix and match your strings, your numbers, so on. But each array is separated by a comma. So here we have an example. So we have the address, which is a key, followed by the colon, and then we have a square bracket. All right, so this tells you it's an array. And then we go through and have multiple key pairs separated by commas. So here's our key in the quotation marks, separated by our colon, followed by the value. And then each key pair is separated by a colon. And as we go down the array, we rinse and repeat as we need to. But making sure we close off each one. So these are lines in the, or lists within the array. Remember, we close off the array. We opened it with an open square bracket. You need to close it with and then close it. So this is where the hierarchical structure comes into play. Now this is much, if you think about it, when I compare it to list, this would just use normal brackets and you would have the same symbol being repeated for every open and closed situation. It was very easy to lose track of where you were. At least with JSON, we're using a combination of brackets and braces, and so you can see a visual difference. So for an old person like me, I can see the advantage of it. YAML is another human readable data format, and it's considered to be a superset of JSON. So in other words, we can both read and write from it. And it uses indentations to define its structure, and doesn't use brackets or commas. So it's containing the same information, but it's using the indents to segregate the information. So you'll see where we have all the brackets and the commas in the left, which is JSON, and then YAML is a much smaller subset without all the brackets. Please note that the hyphen is used in this example as a syntax item to separate the elements of the list. Next, we have the old XML. So anybody that's done HTML programming will know the language has the usual tag, data tag, descriptive. So we have the / with the key to open and close the object. Okay, so the key is what's used to define a tag. As I said, you're all very familiar with it because I know you all remember that beautiful, horrendous amount of time that we spent doing HTML pages last year, and you remember it all, right? Yeah, I hear dead silence again. All right, so should be a very familiar format. We're going to have our tags being opened and closed, and our values and key values being represented inside. So just as we're going through our array, this is the name of the array, here's our addresses and net masks, and we close off each one, open a new one, close it off, and then close off the array, then close off the routine. So, what's an API? So, it's an interface point, application interface point. All right, so basically, if we want to look at it in a human application, when we as a customer put in a request from the waiter is our interface point. They're the ones that interface with the kitchen. So if you want to think about it in terms of us placing an order at a restaurant, we're the customer, we give the waiter our order, and the waiter relays that order into the kitchen, and then the kitchen responds with a response, i.e. our food, and the waiter brings us back to the table to us. So this is the same approach with data. So we're now the user, we request information via the API, it puts in the request to the appropriate application or data set, and the service gives a response to that request, and the API forwards that to us as the users. So it's a fairly simple concept to follow, I'm hoping. So what's the example? We tend to have these little forms in our pages and our user interfaces that basically we fill out some information. Okay, so here we are filling out, wanting to book a flight. We need to tell the application we want to depart from a certain city, going to what sort of time frame do we want, and it'll send off a request to the airline's database, and the database will respond going, well, this is what we have, make a choice. So what's actually going on? When we fill out this information and submit it, the API is making many requests of all the different airline databases and their APIs. So our web page API is requesting information from all the interface points for all the individual airline databases. They will all reply to our web pages API. It'll compile the information and show it as options on the interface. So we need to make a distinction between open, internal, and partners. So open or public APIs are, as the name says, they're open to the public, they've got no restrictions. All right, so internal or private, these are used only within the organisation or company's database, and the information is for only the organisation's use. So to give an example, is an API is used to authorise salespeople access to the sales information for a remote device, for example. Partner APIs are used between a company and its business partners, such as the example we used where a travel company accesses the airline's databases on their behalf. All right, so it's basically a third party being authorized to access the company's information. So these APIs come in four main flavors: simple object access protocol, representational state transfer, extensible markup language remote procedure call, JSON remote procedure call. These have all been available around the 2000 mark, JSON being the youngest, being in 2005. So they're all fairly well established. REST is more flexible formatting compared to the others, but JSON has simplicity in its favour. Moving on to REST and RESTful APIs. So, simply stated, these APIs run on top of HTTP, and they define a set of functions that developers can use to perform get and post messages effectively. So if it's got a client server format, there is no client information stored on the server between these requests. It's considered stateless. And with each client request, the response can be cached to improve performance. If these three measures are met, it's known as RESTful. So that it is still in the REST architecture, but it meets these three precise requirements, and the APIs are referred to as a RESTful API, in that it can be implemented and be able to be more responsive because it is a anonymous system. It's cacheable and more responsive. These operations are supported via the normal HTTP underline, but the APIs use new words for them, but they do basically the same thing. They create, they read, they update, and they delete. Because if you're making any sort of application to automate an underlying protocol, guess what? You can't suddenly add things in that the protocol doesn't support. Excuse me. So RESTful APIs are identified using specific characteristics. Uniform resource name and uniform resource locator, which we're all used to using with HTTPS. Okay, the URN can identify the resource without a reference to the protocol, whereas URL has to reference the protocol. So URI is, built in and uses a specific set. So it identifies the protocol, the scheme being used. So this is where our protocols, our HTTPS, that starting part. We have the host name, where we're going to, the resource. The path and file name within the resource. And then a fragment, if we're looking at a specific page. So what is the anatomy of a RESTful request? Well, we need to identify the API server, what resources we want to have access to, and then we have to define our query. Now, a query has a format, a key, and the parameters that we want to gather. So what does this mean? Well, the server is our URL that we want to access. The resource is what we want to gain information from. The format indicates the dataset format that we want to use, whether it's JSON, YAML, XML. The key, remember we always have information stored in pairs, and the key is our name that we're trying, of the area that we're trying to access, and then the parameters are what we're requesting. So we want information about San Jose, California to Monterey, Cont. So what we're asking for is a set of directions to get from one location to another. So we need to be able to provide keys while we're requesting information. Now, what are the keys used for? They authenticate the source to make sure we're authorized to use the API. We can limit the number of people using the API. We can limit the number of queries per user. And we can track who is making what queries on the data. And more importantly, especially for big business, we can gather information on the people using the API. So who does this on a daily basis? Every time you use a search engine, you're providing information as laid out here to that search engine owners via the APIs. Now, I know you don't have Google over there as the primary search engine, but I can tell you for us here in Australia, every time we do a search, it's propagated. All the similar activities start flooding our feeds in advertisements as Mr. Google is in the business of selling ads. And if you make a query, they want to know about it so they can place appropriate ads on your interfaces. So that is what they're using to keep track of what you're doing. So the request can be made via other ways. We can go via a specific developer website. These are specific sites that allow you to enter search parameters to get specific information. We can go via Postman applications for testing whether we have a RESTful API, and it'll help us fine tune if you're using the API correctly. Python can call APIs within any of the code generated within the Python. So this allows us to do automation and customization and integrate other apps within our coding. And network operating systems such as netconf can be incorporated and used with APIs. Configuration tools. There's a lot of them. All right. First one we learnt about was the command line interface. All right. This was the first configuration tool we were exposed to many moons ago. Then we started looking at management systems that used simple network management protocol to monitor all these devices as we had bigger and bigger, more complex networks evolve. We wanted to automate monitoring so that we could keep an eye on things. Now, this protocol is no longer normally used because of its security concerns, and security and SNMP sort of aren't really compatible with each other. So we have to manually configure all of our things. Now, we're moving away from where administrator just looks after a few dozen devices. We're moving to a more complex world where enterprises run over much larger domains, and they're wanting to reduce their costs by reducing the personnel responsible for supporting their more and more complex networks. I know it's not intuitive, but business is always trying to maximize profits. So to do this, we need to have automated systems. This means fewer people are required to make changes, and the system can make changes rapidly, and they need to support appropriate technologies and protocols to make this happen. So this is where all of the things we've been talking about come into play. REST, JSON, XML, Python, and Ansible, Puppet, Chef. There's lots and lots of elements that help with automation and monitoring. So this configuration management suite of tools can automate based on characteristics. So we can control software and versions. So if we need to update all the machines running a specific application to a specific version, we can put it in a policy and have it pushed out as those devices log into the network, for example. We can control devices based on their attributes, their protocols that are in use, and we can filter based on ACLs. So this allows us to automate a lot of tasks, which results in a coordinated process or workflow throughout the entire network. So what tools are available to make this easier? Ansible, Chef, Puppet, and SaltStack are just some of them. And I dare say Cisco has an interest in all of them in one way or another. So what programming languages are supported by these four things? Well, Python, RN2, Ruby, RN2. Agent-based or agentless? So, in other words, do we have to have a small application on the clients? How are the devices managed? Via a controller, which can be any device that we define. Ansible does this. Whereas the other ones have to have a specific master that is defined and dedicated. And they have their lovely tool name. So playbook, cookbook, manifest, pillar, all sort of going in the naming convention of themselves. So what's the take from that? There are many, many management tools out there, and you need to do your research and select the one that meets your requirements. Intent-based networking. So this is the next generation coming out, and it's, you know, the second generation of software-defined networking. So this is transforming from hardware-centric and manual approaches to designing and operating networks to a software-centric, fully automated system. So the objectives are expressed as intent, and the IBN system captures the business intent, uses its analytics and machine learning and automation to align the network to those objectives. This is being done continuously and dynamically as the business changes. So how does it do it? Well, it takes it from the policies and automates it and applies it consistently across the network. So we have a system that takes our intent. In other words, we need to translate the business words and express them in policies that can be implemented in the network. The activation is, as it says, the actual placement and functioning of those policies across our physical and virtual infrastructure via automation. The insurance is where we continuously check and make sure that the intent is being honoured or followed, however, whatever words you wish to use. So this is, if you like, our quality assurance method. So we're in a loop. We have some goals, we're translating those goals into policies, we're implementing those policies onto the infrastructure, and we're monitoring that infrastructure to assure compliance with those policies. It's a continuous loop. So we need to continuously deal with both the physical and virtual infrastructure, because we can't just have virtual infrastructure. It doesn't exist. We need to have something that runs it on. Okay, so that's never going to change. So we need to have some way of communicating this over those systems. And this needs to be done in a secure manner. So we need to encapsulate those protocols that overlay our control onto the devices. And one of these ways that we already use is IPsec and CatMap. So these are going to be used to expand into the next generation of software-defined networks, which are intent-based networks. So we're going to control the devices using the policies. So this, as I keep saying, is the next generation of software-defined networking. The only difference is we're going to start automating a transition from business requirements to network policy. The rest of the infrastructure and the way we define it and make changes is already in place if we're using software-defined networking. Yes, that's what all those words basically boil down to. So DNA, digital network architecture. Fancy new words and marketing to do what we do. So we need to transition between our policy, automation, analyze and learn from what we're doing. This is a standard project model. Continuous improvement, it's been called that for decades. All right? They're just applying continuous improvement methodology to network automation. So nothing new here. We're just applying decade-old processes to new technologies and keeping the mechanism in a loop of self-improvement. So software defined access. This is where we gain access to the network. And the benefit of using this is that users can get access within minutes of being authorized. And then a WAN solution, SD-WAN. So this allows us to give our users better experiences across the entire network and greater agility for the company. And what does this mean? It means we're just going to continue what we started with software-defined networks, just going on a progressively wider scope. Assurance and security, again, doing exactly what we're doing, but getting it more automated and more trusted solutions and applying it across systems with self-checking algorithms. So the DNA Center is our control and analytical platform. It's the heart of the system, and this is where all of our automation, provisioning, and policy-based segmentation originates and is pushed out across the network. It's the point where we interface with the automated system and can get our reporting back to us. So we get a summary and snapshot of the entire network, and at our leisure we can drill down on any point of interest. So it's a GUI. All right. It is a web interface. We're all familiar with how web interfaces work. We click on the highlighted little section and it dives us into a new web page with more information. Nothing new here, just the presentation. I'll let you read all the words, but basically all it is it's a new GUI interface that you can drill down on the very specific areas of the automated system and get specific information containing to that area, just like all the other GUIs. So IBM is going to be the second generation of SDN. So what do we learn? We learned that automation is going to be self-driven with the goal of reducing the need of human intervention. Okay, we want to get these applications and tools to be thinking smart. In other words, we want to give them the appropriate depth of pre-thought out solutions and questions so that they can step through analysis and come to a way of implementing a solution. Now, these automation machines are only as good as the programmers that program them. And if they didn't come up with a pre-thought up solution, then the tool's not going to come up with it either. Now, this comes back to an old fart like me being taught by mathematical genius in programming of electronics and that, where all this started from. Going, any application or program is only as good as the programmers. Now, as the programmers are human, we are prone to mistakes and errors, and so will the tools that we create. So, this is all pie in the sky until AIs are a real thing and don't require a huge CPU and resources to work in any usable function. We're still going to have just a program that is based on a series of choices. All what we're doing is we're automating the inputs and giving it the scenarios to make its choices from. If these inputs equal X, then the solution is Y. That's what all these automated tools are going to be. So there will always be people needing to program these and implement them, and to fix the mistakes that they create. I've seen it many times over the years, so don't get stressed about, oh, we're going to automate ourselves out of business. No, we're just going to create new ones. As one of the old engineers I worked for said on many, many occasions, for every engineering solution, we create 2 new problems. All right, so we're going to be around for a while. The formats that any language uses have a syntax to them. They always have, always will. Now, the ones we looked at have very similar language and syntax, and most of them were in a readable format that us plebs, us little humans, can read. Now, there's been many languages over the years that use this approach to programming. Okay, and they're very, very accessible. We then looked at what APIs are, being interface points. We looked at whether they should be internal or public or partnership APIs, and why we define them as that. We then went through and looked at the various types of APIs that can be used. We talked about 4 main ones. And then we talked about the fact that these APIs generally run and use an underlying protocol, so they need to call the functions of those protocols. They may change the names of those functions, but they're basically the same thing. We then looked at the naming that these APIs use, and the fact that the only difference between an earn and a URL is one doesn't specify the underlying protocol and one does. And they wish to get access to those resources and pull specific information from that resource. So we looked at the query language of how they can extract that information. We then looked at the basic languages that these management tools use to customize these APIs. We then had a look through the fact that the new intent-based networks are the next generation of software-defined networking, and they are just taking us in the next step of automation and are fine-tuning the services offered under SDNs. They still provide the exact same services, we're just fine-tuning them and trying to make them more automated by including this continuous improvement mechanism into the process. And that was basically the last 10 slides. So that brings us to the conclusion of the chapter. It also brings us to the conclusion of the theory for the ENSA course. So now we'll be just concentrating on wrapping up the exams and the assessments laid out, and then we'll be expanding on some of the concepts in defining security perimeters and so forth, and because there's one other networking subject, and the others are going back to our web and database solutions. So this brings us to the end of this round of theory. Any questions? The usual loud chorus of questions. Okay.